Hi students, in today's class I am going to explain some important concepts and numericals in electrochemistry chapter. We know that some substances allow current to flow through them. We call those substances as conductors. Like, yes, this is an example for conductor. And some substances do not allow electricity to pass through them. We call it as an insulator. This is an example for insulator. Conductors are of two types: electronic conductors, electrolytic conductors. If the conductivity is because of the electrons, we call it as electronic conductors. If the conductivity of the solution is because of the presence of the ions, then we call it as electrolytic conductors. Let us see the conductance of electrolytic solutions. Every substance offers resistance for the electricity to flow through them to a large or small extent. Resistance is nothing but the hindrance provided by solution on the passage of current is called resistance. Few substances shows resistance to small extent and a few substances shows resistance to a larger extent. And suppose this is a wire. Through this wire, at the end of this wire, if you pass a voltage V, then I is the amount of current passed through it. Then resistance R is equal to V by I. V by I. V is nothing but voltage and I is the current passing through it. We measure in amperes, and resistant unit is ohm. Ohm is equal to voltage by ampere. Voltage is nothing but work done per unit charge. So ohm is equal to work done per unit charge by ampere. Work done by unit charge I am writing as W by charge into 1 by ampere. Work is nothing but force into displacement. I am writing as F into L by charge is equal to Q is equal to IT. I is the amount of current passing in time t seconds t. I is measured in ampere A, time in seconds, into 1 by A. Force is nothing but mass into acceleration into L divided by A square into S. Mass unit is kg, SI unit. Acceleration meter per second square, and length meter by A square into S. So kg meter square by A square S cube is the units of resistant ohm. This is very important concept, students. Listen carefully. Resistance is directly proportional to the length and inversely proportional to the area. Then R is equal to rho into L by A. This is a proportionality constant, where rho is resistivity or specific resistance. Resistivity is more preferable according to IUPAC than specific resistance. Let us see the units for resistivity. Resistance unit is ohm, length centimeters, area centimeter square. So resistivity rho is equal to rho, RHO. Resistivity rho is equal to ohm centimeter. This is the unit of resistivity. And We know that conductance is inversely proportional to the resistance. More is the resistance and less is the conductivity. Less is the conductance means more is the resistivity. Conductance is denoted by the symbol G is equal to 1 by R. 1 by R means R is equal to rho into L by A. 1 by R means 1 by rho into A by L. 1 by rho is nothing but K. K stands for conductivity. Kappa. K stands for conductivity. Conductivity or specific conductance. Specific conductance. According to IUPAC, conductivity is more preferable than specific conductance. Let us see the units of this G. Conductance is inversely proportional to the resistance. So resistance unit is ohm. Then conductivity unit is ohm inverse. Can write like this also. Ohm inverse is nothing but Simon. S. Simon. It is denoted by the symbol S. So we discussed resistance R units ohm and rho units ohm centimeter and conductance units, that is ohm inverse. Let us discuss Kappa conductivity or specific conductance units. Kappa is nothing but K is equal to 1 by rho, which is inversely proportional to the resistivity. What is resistivity units, students? Ohm centimeter. So ohm centimeter. Then Kappa unit is ohm inverse centimeter inverse or ohm inverse meter inverse. And 1 ohm meter is equal to meter inverse, not meter inverse. 1 ohm meter is equal to unit for rho, ohm centimeter or ohm meter. 1 ohm meter is equal to 1 meter is equal to 100 centimeter. So 100 ohm centimeter. 1 ohm meter square, put square of this, then we'll get 10 power of 4 ohm centimeter square. If 1 ohm meter is equal to 100 ohm centimeter, then 1 ohm centimeter is equal to 1 ohm centimeter is equal to how many meters? 10 power of minus 2 ohm meters. 1 ohm centimeter square is equal to how many meters, students? 10 power of minus 4 ohm meter square. These are the conversions during little tough problems. These are useful for you. Conductivity of solutions of different electrolytes in the same solvent and at a given temperature differs due to the charge and size of the ions in which they dissociate. That time two terms are very important. One is equivalent conductivity, we should have an idea, and another one is molar conductivity. Equivalent conductivity is nothing but for a solution at a dilution V is defined as means equivalent conductivity of a solution at a dilution V is defined as the conductance of all the ions. Conductance of all the ions produced from 1 gram equivalent of an electrolyte when it is dissolved in V centimeter cube of the substance. What, students? 1 gram equivalent weight of an electrolyte is dissolved in V centimeter cube of the solution. That time the conductance of all the ions produced, we call it as an equivalent conductivity when the distance between the electrode is 1 centimeter and the area of cross section is so large. Then we call it as the conductivity, we call it as an equivalent conductivity, which is given by lambda. This is lambda. you can write this is a lambda, this is also lambda. Lambda of equivalent conductivity is equal to K into 1000 by N. Let us write the units for equivalent conductivity. K units we already found. What is the units of K? K is equal to 1 by rho, we wrote. 1 by rho unit is ohm centimeter inverse. So K units we got ohm inverse centimeter inverse. Write that ohm inverse centimeter inverse, and 1000, this is the volume, means centimeter cube per liter. Liter inverse I am writing. Normality unit is gram equivalent per liter. So gram equivalent liter inverse I will write. Then the units of equivalent conductivity is ohm inverse centimeter square gram equivalent inverse. This is the unit of equivalent conductivity. Molar conductivity also same, but when the conductivity of a solution at a dilution V, it is produced, the conductance of all the ions produced from 1 mole of an electrolyte. This is 1 mole. 1 mole of an electrolyte is dissolved in a V centimeter cube of the solution. That time we call it as a molar conductivity, which is given by molar conductivity is equal to K into 1000 by M. Let us find the units for this. K units we already found, that is ohm inverse centimeter inverse. This is the volume centimeter cube per liter divided by molarity, mole per liter. Mole per liter. So the units are ohm inverse centimeter square, mole inverse is the unit of molar conductivity. And one more thing students, resistance R is equal to rho into L by A. What is L by A? L by A is nothing but it is the cell constant. What is L by A? It is a cell constant. And rho they give in the question, and R they will give in the question, and sometimes they ask you to find cell constant. This is a useful formula. And we know that R is nothing but conductance, which is inversely proportional to conductance. So we can write 1 by G. Rho is nothing but 1 by K, because Kappa conductivity is inversely proportional to the resistivity into L by A. If they gave conductance and conductivity, we can find cell constant. Therefore, cell constant is equal to, what is the formula? Cell constant is equal to conductivity by conductance. Sometimes they give you conductivity and conductance, you can find cell constant. Sometimes they ask you to find conductivity. Conductivity is nothing but a specific conductance K, which is equal to cell constant into conductance. If these two values given in the question, you can find the conductivity. These are very useful formulas and their units, which are useful for your competitive exams a lot. Let us discuss some important numericals which is useful for both PU as well as in competitive. Let us see the numerical. The conductivity of 0.20 molar solution of KCl at 298 K is this value. Calculate the molar conductivity. What they are asking students? Molar conductivity. How to find molar conductivity? Conductivity into 1000 by M. What is the conductivity given in the question? 0.0248 into 1000 divided by molar conductivity value is molarity is 0.20. Find the value. 124. 124. What is the units for molar conductivity? Ohm inverse centimeter square, mole inverse is the unit. We already discussed how to get the units for these terms. Let us see second numerical. The resistance of a conductivity cell containing 0.001 molar KCl solution at 298 K is 1500 ohms. What is the cell constant? We have to find cell constant for the same solution at 0.146 into 10 to the power of minus 3 Siemens per centimeter. This is the conductivity given. What they are asking students? Cell constant. And what is given in the question? Resistance R is equal to 1500 ohms and conductivity K is equal to 0.146 into 10 to the power of Siemens per centimeter. They are asking to find the cell constant L by A. What is the formula? R is equal to rho into L by A. R is equal to rho is nothing but 1 by K conductivity into L by A. L by A is equal to cell constant is equal to resistance into resistivity. Resistance into conductivity. What is the resistance? 1500 ohms into conductivity is 0.146 into 10 to the power of minus 3. Then 0.219 centimeter inverse. This is third numerical. These are very important and useful. Practice a lot. Resistance of a conductivity cell with 0.1 mole per liter KCl solution is 100 ohms. If the resistance of the same cell when filled with 0.0, this is another solution KCl with different concentration and its resistance is 520 ohms. Calculate the conductivity. What they are asking students to find conductivity and molar conductivity of 0.02 molar KCl solution. And what is the conductivity given for 0.1 mole per liter KCl solution? 1.29. This is the conductivity given. See here, first thing is 0.1 molar KCl solution. What is the given data for first solution? 0.1 molar KCl solution. Resistance R is equal to 100 ohms and its conductivity K is equal to 1.29 Siemens per meter. This is for first solution. And for 0.02 molar KCl solution, resistance R is equal to 520 ohms and they are asking to, and concentration also they given 0.02 molar. M they gave, concentration M value they gave, and they are asking to find conductivity for second solution 0.02 molar solution and molar conductivity lambda M. We know that molar conductivity is equal to K into 1000 by M. M is 0.02 and K we have to find. How to find K? First see this, R is equal to, we know that 1 by K into L by A. Therefore, cell constant L by A is equal to R into K. R into K is nothing but R is 100 ohms into 1.29 Siemens per meter. This is, then we will get 129. This units is ohm and this is Siemens meter inverse, or we can get 1.29 ohm Siemens and ohm and Siemens is nothing but ohm inverse. Both gets cancelled and meter inverse we can convert into centimeter inverse. So cell constant is 1.29 centimeter inverse we got. And let us see for second solution 0.02 molar KCl solution. Resistance R is equal to 1 by K into L by A. And we got cell constant value and resistance already given in the question. Then we can find conductivity K is equal to, what is that? Cell constant 1 by 1.29 divided by its resistance is 520. Then we'll get What is the units for this, students? Centimeter inverse, and for this is ohm. 1.29 divided by 520, we get 2.480 into 10 power of minus 3 ohm inverse centimeter inverse. Ohm inverse centimeter inverse. This is the conductivity, and next one is molar conductivity. After knowing conductivity, it's easy. Just to substitute here 2.480 into 10 to the power of minus 3 into 1000 divided by concentration is 0.02. You will get the answer. We get 124 ohm centimeter square mole inverse. See students, whenever they give R and K, directly you can find cell constant. If they gave K and M, we can find molar conductivity. If they gave for two different solutions, first find use the given data and find the required, for which is useful to find in the second solution the required thing. This is some important concepts and numericals in electrochemistry. If you find this video is useful for you, please click on like button and share this video to your friends, and subscribe my channel for getting more updates in chemistry.